Hello everybody, my name is Rich Bensley and I work for MariaDB. I'm actually a software developer. I'm working on the monitoring team for SQL, our new cloud platform. But I've been invited to talk about my little talk that I've entitled SQL mode equals ludicrous. I've got about half an hour with you all just to cover a couple of scenarios of how I've used MariaDB in production environments in probably the most nonsensical ways possible, or at least how I've used some of the more interesting underlying features that I've previously found as a DBA to really help me out in production environments, not just in production has failed or something has gone wrong, but also how I've kind of used a few little things in system design, which I've had to like design, create, maintain, which has actually helped our environment. So I hope you enjoy it, and we're going to have some fun now. I'm gonna kick off with my first example using my favourite tool. The connect engine on MariaDB. I was a very early adopter of MariaDB 10 when it came out, and the connect engine was one of my absolute favourites. I was working in a mixed database environment, so I jumped onto the ODBC connector very quickly to start querying other databases, not just MariaDB, from afar. I started using SQL from a database to query other databases, and I'd use it for reporting, materials I use, data warehousing, ETL, ELT, all sorts. The Connect engine documentation is vast, and it supports more than one table type, not just MariaDB, not just ODBC, but all kinds of table types you can start using. And one stood out to me in particular, which is the ini table type, which also happens to be very similar to the server config file format. I thought this could be quite interesting. How can I use this? The ini table type itself is what's called an outward table. So that means when you create the table definition inside MariaDB using the Connect engine, you have to define the table name. And I did actually have a use case for this. If I just get back to my terminal, there we go. I've got Linux, MariaDB 5, 10.5. Not 5, that'd be very, very old. 10.5 running on Linux. I've got a little custom environment here set up in a way that kind of resembles some of the production environments that I encountered before, and it'll kind of take me through these scenarios. So I had this scenario where MariaDB was new to us, MariaDB 10 was new to us, and so was Linux. We're still mostly on Unix at the time. Still, after 2010, there's still plenty of Unix shops out there. And whilst the sysadmins and DevOps trying to figure out what the DBAs should do now and where the database should live, they just gave us a directory and said, you own this, you run everything as this user, and you've got some network mounts. I said, that's fine, we can just customize everything like that. In this case, we had a /mountdb kind of looking thing, and I just kept everything in one place. I could demonstrate that inside the server config, quite simple. I'm just foreseeing the socket connection for some clients in case they need it, because the default Unix socket authentication is fantastic, but I do just have to tell it it's not a default location, as I have customized it to be inside this directory. My Linux user is Vagrant, as I'm using Vagrant in VirtualBox to run this environment. So I'm running the database as this user on this system, not using the typical MySQL Servers account. So in theory, the DBA owns this environment, the files, the data directory, everything involved. And I've got just about everything I need here for the examples I'm going to be talking about today, including the Connect engine. So in that scenario as well, like you can see, I've got plugin load HA Connect, so it will load on startup. And if I just go to the server now, show engines, I've got the Connect engine listed there. There we go, that's fantastic. So I had an environment where I could edit a lot of the server configs. well, we could edit a lot within directories, but we actually packaged this stuff and we had to move it away. So we didn't always have SSH access to a box. We just package the database up with everything we need in SQL, baseline schemas. We could get it up and online from far away. Then we could connect in, perhaps set replication properties if we needed any, and whatever else we need to customize. So we didn't always have file system access. This is very important. We own these data directories, we own these databases, but we didn't always have file system access. Here, enter the Connect engine in the table type. So we normally have, I think most people have probably seen this in their environments. They've got a schema or a database called DBA. In there is all your DBA tricks. And I've just got one table in here today called CNF. I'm also going to show you how I made that with a show create table, CNF, XG. Here we go. So I've got quite a simple table definition, and this actually matches the config file format that I showed you previously. That the database that MariaDB is running, and it owns that file. It's got permissions for that file, so it's using the same user. And it's an outward table, so I've got a file name defined. The engine is connect, and of course my table type is ini. So let's have a look at what this table actually looks like. Let's select star from CNF. It's not a huge table. There we go. There's that ini file. There's that server config as a table. Let's update it. Actually, John, I've got a copy paster over here. I'll just grab this, run that. Oh, and I included the end of line as well, so it ran it for me. That's great. Just to go over what I did, I updated the table and I set the variable value for the log output. For those that do or don't know, the log output changes where the slow query log and the general log goes. So it defaults to file, and I did say file inside the config. But you can also set the variable value to be table, and they appear inside the system schema. So I was very specific. So with variable value, with the variable name equals log output, and the section equals MySQL_D. So it's quite handy that you can see my client section is up there. I said I had to specify the socket for my clients. And previously the log output was set to file, and I just updated it to table. Let's select star from CNF. Let's have a quick look. Ooh, it worked. I just updated the server config from the SQL prompt, potentially remotely. This is extremely dangerous, but it's a lot of fun and could be quite useful in some scenarios. And I definitely found it useful where they kind of set a database up for me. They want me to connect in and test things, but things aren't quite right. If I wanted to get something changed, it might take an hour, it might take a day, I might have to wait to a change management window before I can actually make that change. Some things like this are a little innocuous. Of course, if you have a change management process, I'd stick to the change management process. But it was a nice little addition, and for various other table types like JSON or CSV, it was nice to have another method to connect in, edit and read files, particularly as a DBA, particularly in restricted environments. So that was quite fun. I was going to set that back. I was going to update that back to a file. I don't want any surprises at the moment. I was going to shut down the instance as well and maybe restart that and make sure it comes back. Do not want a dying instance during a presentation. That would be terrible. Show schemas. Are we there? Show process list. We're up and running. Select log output back to file. That's fine. Okay, so that was quite fun. And that in the same place, again, working with restricted access and having to go through jump hosts and things to gain access to production instances, we had a production instance which failed. And I like to call this little scenario the backup battle royale. So we had a failing instance, and everyone was looking at it. I myself had a remote SQL shell logged in, similar to the very dangerous Connect engine session I had open there. So I could actually poke around the database to see what was going on. There was minimal database activity, which was good, but the rest of the system was having lots of problems. and this system was going down. The sysadmins told us, this system is going to go down, and if it doesn't, we're going to take it down. You need to put your stuff elsewhere. So, well, okay, we could do that, but the backups were from this morning, and they were already too old. The rest of the business was adamant we needed up-to-date data. So, okay, well, we can't get the bin logs. When they tear that system down, the binary logs are going to go for whatever reason. I was the last user left alive. I had my SQL session, but we also had one extra thing, which was the backup. Where we put the backups was a network mount, and the database could write to it. And I whipped out my favourite tool, Outfiles. I'm sure people have used Outfiles on and off over the years. It's by far one of my favourites. It's so simple. Along the vein of Connect Engine, I can just interact with the disk as well as remote things. And I can put files, I can just select data and put it on a disk. The default format is tab separated, so I'm going to use the TSV as my extension when I start working with things in a moment. And I've always found this super useful, not just in some odd backup restore scenarios like this, but also just in, lots of people have probably used it for ETL, ELT, for loading in and out of column store in particular, or another system, or just doing an archive backup, export into CSV, TSV, upload to a bucket like S3. However, in this scenario, I was trying to get up-to-date data from a failing system. I've got a database in here called Jam, which is a fictional jam factory where you can order jam from. And I've got some tables. Let's have a look at some tables. There we go. Let's select start from T_jam orders. Oh, well, it's 10,000 rows. I was going to do a count. There we go. Count 10,000. Don't want to see every single row. That'd be terrible. Good thing there wasn't a billion rows. Good thing this wasn't column store. That'd have been many more rows. I'm just going to create, for this example, I'm just going to create and load a table locally from disk using the in-file, out-file interface. So I'm going to select everything from the jam orders table and put it into another table. So in my actual scenario, these were remote databases. So what I'd export from one database and put it somewhere else. So we can get your database up and running somewhere else. Give me 20, 30 minutes and I'll get it done. It wasn't a huge database, but it's still important data. So I'm just going to create a new table like that table, and I'm going to call this new table New Table. Next, I'm going to select star from jam.t_jam orders into outfile. This is where the magic happens, and I'm going to specify a path of where I'm just going to write to temp. Everyone can write to temp. That's very handy. I'll call it jam orders dump.tsv. There we go. And I've exported 10,000 rows. Let's have a quick look at that on disk. WC-L temp jam orders dump.tsv 10,000 rows. So if I just tail the last 10 lines, you'll see that this is just a, so this is a row per line inside the file. And you see it's tab separated. That's the default format. You can specify more options, as you can see in the documentation. Well worth reading. You can specify the delimiters and what it's terminated by. Particularly handy if you've got perhaps some funky characters going on inside your database tables. But we don't for this scenario. Pretty simple. Date times integers. Nice and easy. I'm just going to go back to the jam database. I'm just going to select count star from new table. Nothing in there, that's fine. Now I'm going to load that table using the exported data. Load data in file, and it was /temp/jam orders dump.tsv into table jam.new table. Genius naming. Load data in file into table. There we go. I'm just going to select from that table again. Select count star from new table. There we go. Show create. New table. there we go, just the regular InnoDB table, and we've exported the data to disk and loaded it from disk. So in my scenario, that was a network mount, and that was a lifesaver. We kept all the schemas inside version control, and I always thought if that wasn't there, my last-ditch effort would have been to clear my terminal, did a show create for everything, every store procedure function, every table, and put that somewhere else, then just do the load data. Thankfully, we did have the schemas and all the database objects inside version control, so I could quickly get that up to date, restore the backup, then just load the difference. For a couple of tables, I just dumped and loaded everything. For some, I loaded the difference, and that was a lifesaver. That made a big difference. I'm just going to drop that table now. Drop table, new table. I'll get back to where I need to be for the next little addition. Oh, just one caveat for in-file out-file. The only caveat which you might encounter when using this is so that file already exists, the out file I created. So if I select star from jam orders into that same file, the file already exists. That's the only caveat with the in-file out-file interface. If you're creating files, you do need to make sure that what you created doesn't exist before you do it again. So it's a shame you can't overwrite it. I guess it's kind of a security feature. And in better practices, I'd script this and I'd append a timestamp or something to the end of the file name. So it's a little bit more descriptive other than just this. But for an example, it's fine. Now I can run it and it's fine. Okay, let's go remove that file again. Right, let's clear screen and go on to the next example. Casual conversation one morning with a colleague. Somewhere, someplace, sometime. They were developing a new system, and MariaDB was now the new tool of choice for everyone, which is good. We did our jobs as DBAs. We canvassed development globally, and we got them convinced, and they were all very happy, and they'd already seen some of these kind of other things we were doing, so everything was working very well. Until the conversation came up, we've got something new, but if it gets big, how do we scale it? I said, well, don't worry about it for now. I said, let's just get binary logging enabled, and then when you're ready, we'll come do a bit more consultancy with you, and just set the bin log format to row. That's all we're kind of looking for, and just make sure the expiry is longer than the restore time. We said, well, what does that mean? So you've got an option to set the binary log expiry. So if it takes a day to restore your database, you need at least 2 days worth of binary logs. So if that restore doesn't happen, you're going to need to, if you've got another server downstream or upstream that's serving requests, and they're kind of running out of time, you need to make sure your backups and your binary logs are all in sync together. So you back up and restore to a certain point, then you might use your binary logs to do a point-in-time recovery to restore up until it's absolutely necessary. For some people, just a daily backup and restore is fine. But for a lot of customers, the scenario is a bit like that in-file, out-file scenario. Bin logs weren't available. We couldn't use a backup. It was too old. Or the backup was up to a point. So I essentially did a point and store recovery with TSV files, just plain text files. And it did kind of work. In a normal scenario, you'd use binary logs. It's a much more robust scenario, robust solution. As I say, take a lot of this with a grain of salt, but I had a lot of fun in production with MariaDB, and we solved a lot of neat problems. So anyway, I don't hear from this team for a little while, and suddenly they call up and say that the customer's using this instance. Okay, how can we help? Well, we need to dump and restore it to another database, but we don't have any backups or anything, and in fact, we kind of lost access to this instance. It broke and they need to restore it. That's essentially, it broke and we need help. But they didn't have any backups. However, they didn't actually set a binary log expiration. Because they didn't have any backups, they didn't have something to set it to. They said, well, we'll just keep it forever. I said, that's even better. That's fantastic. Don't worry about the backups. We'll get you up and running on a new box, and we'll apply our DBA standard to it. So there's monitoring and backups and point-in-time recovery and alerts, and we'll just restore the entire database using the binary logs. They thought that was magic. I'm going to quickly whip through this example. I'm going to use my jam database. again. I'm just going to show you there's nothing up my sleeve. I've got some different queries just to make sure I've got what I need. So if I select count a sum from the orders table, there we go, a sum of just about 1 million orders. And now I'm going to just delete everything from these tables. Just do a quick sum again. Okay, just going to look at my existing binary logs. Now I'm just going to wipe out these binary logs. I'm just going to reload this database for an example. So if I do a quick select star again, so these tables are now empty, and it's a fresh database, if you like. I've got no more binary logs. If I show binary logs again, we're back to nothing. Okay, so I'm going to emulate the scenario that we are in just by using a little Python script I put together to populate the Jam database. So I'm just going to load that with data. So in theory, they started a new instance, they started loading data, they were creating tables, creating schemas and objects and all these kind of things. And while they didn't have a backup, they did have the entire binary log history. So in my case, this is only going to be inside one file. We started at 325 bytes on binlog 00001. If we just go have a quick look at the database and show binary logs, we'll see that the position counter has now moved on because we have loaded data. Now, just to have some fun, I'm going to, again, I'm just going to flush logs to move me along one log. So now we should have 2 binary logs. There we go. So now everything I do new will be recorded inside this next log. Easy peasy. And in this new log, I'm going to delete everything again. Oops, let's use Jam. And let's just delete everything again. So if I run my quantifier, there we go, aggregate function. We're back to 0. We're back to no rows. But that's okay, because I know there's one binary log there with all the data inside it. So I'm just going to go to db/data. And I am going to use the binary log command to replay the binary log against the instance. I'm just going to copy paste. I'll talk through it rather than copy pasting it. Of course, everyone noticed the new binary names are available. So instead of using MySQL binlog, I'm using MariaDB binlog. The binlog I want is 001. It's the first one. I'm only going to replay one set of database events from the Jam database into the instance, into the database, Jam. I'm just going to let that process. Perhaps I can see what's going on inside my show process list. There we go. So that's going to go through. But, oh, we're done. It was too quick. Too quick. Okay. -A, Jam. Let's go back to the database. So we had no orders before. Let's do a quick quantity on there. There we go. Fantastic. Who doesn't love binary logs? Managed to restore, dump and restore the entire database using binary logs. Very handy. Right. Hope you enjoyed that one. I'm going to cover one more scenario before I leave you all. I think most developers, DBAs, have come across this scenario before where the first thing, I've heard the story so many times, you join as a new DBA, you don't know the circumstances of you joining or the previous team or people leaving, but you've got like a database, or perhaps you've just been hired for a particular set of databases they've got problems with, and the first thing you do is lock out every single developer. Well, I did need to do this, but I didn't need to be so. I didn't need such a sort of blanket ban of all developers. What I had to actually do was lock them out of different regions, and for reasons I can't disclose, the servers in each region would be rolled over. So the master or the primary would change to each region as the world turned and the sun rose for another day and somewhere else. The new primary would move. But also meant if developers were doing overtime in their region beyond 5-6 p.m, they could stay inside their own region, but they could not log into the new region. And we did that on purpose so they wouldn't fiddle with the current primary. So to fix this, I came up with a solution which I found in the documentation years ago. I'd seen this around init connect and init file. Init file is a server variable you can put in there, pointed towards a file full of statements, and that's SQL that can run during a server startup. Init connect covers SQL, which is executed when any user connects. This is terrifying, and I use this in production to control user access, and I'll show you what I mean. Some of you may have seen inside my config file before, db-my.cnf. I've got a little line up here, init connect call auth check user account. So the connect SQL for me is a store procedure which is run. Let's go and have a look at that. So I've got a database called auth, and this is where I stored everything related to this region lockout mechanism. If I just do show create procedure, check user, I think it should be called check user access. There we go. I've just three variables. Just who is the current user connecting? An integer just for allowed, 1 or 0. 1 is allowed, 0 is not. The process ID, which is the user's current process ID. And you'll see in these, I just set the current user to be the current user from the user function, and I select allowed from a table where username equals current user into the allowed variable, and then I just grab the connection ID into vProcess ID, and if allowed is 0, then this select statement shouldn't actually render anywhere at all, but kill process ID. Just there for just to be a bit more clear, and I just kill the user's process ID if allowed equals 0. So let's select star from users. So everything except my jam user, root user, test user, vagrant. I've got one user here, test user, who's a bit of a troublemaker. Is not allowed to log into this particular region. I used a non-replicated table to maintain these tables in each region, and it worked well. So if I try and log in as this user to this database, it's going to read from this table using the store procedure, and it won't let me in. MariaDB -u is test user. The password is trouble. Okay, I'm in. May look like I'm in, but I'm not in. Do a quick show schemas, for example. Connection aborted. That's it. Init connect command failed. We're done. We're done. No access. Okay, well, let's flip that on its head. Let's set allowed for the auth user. There we go. Select star from users again. There we go. So all users are now allowed. And let's try connecting again with our test user. We'll do a show schemas. Now we're in. Now we can use MySQL and select star from user, because we are a troublemaker. So that was a very simple mechanism. Do I recommend it? No. It takes a lot to maintain that kind of scenario, but if you're comfortable with this kind of like change management and testing, always test, then you'll probably find it a very useful feature. And you could do all kinds of things. The init file I've used quite a lot in container scenarios. So a new server comes up in a container and I just want it to run some extra SQL. Perhaps have a container that's kind of more ready to go, rather than having to load a container as an afterthought. I can have a Docker file or something which actually loads a database on startup. It's probably one of the most dangerous but more interesting variables I've come across, or features I've come across. I hope you have some fun. I hope you kind of come away from this thinking, I'm not doing any of this in production ever. That's good. If you come away from this thinking, I'm going to do some of this in production, that's also good. I highly recommend experimenting with the Connect engine, what you can and can't get in and out. The in-file, out-file interface has been an absolute lifesaver for me. Just get data out, put it somewhere else, bring new data in, script it, automate it. Just remember, you can't overwrite the files. The init file has been a lot of fun for me, and of course, become familiar with replaying bin logs. You can do a lot of magical things, and in that particular scenario, I just restored one database from the binary logs all the way from scratch, and it worked great, and they were really happy. Thank you for listening to me, and I hope you enjoy the rest of the Server Fest.